We're in section 9.4 where we're going to solve polynomials in factored form. Up to this point, we've been solving polynomials as an expression. Now, an expression is a polynomial that has no equal sign. Well, today we're going to kind of go into what is called solving polynomial equations. Equations are polynomials with an equal sign. So first thing that we're going to look at is being able to implement what is called the zero product property. And the definition of the zero product property is if we have constant values a and b are real numbers, if a times b equals 0, then we can make the conclusion that either a equals 0 or b equals 0. It doesn't matter which one it is. We just know that if one of them has to equal 0 if a times b equals 0. So when we're using the zero product property in our examples, we have to make the assumption that either x minus 4 is 0 or x plus 3 is 0. So what we basically get to do is we get to set both of these parentheses equal to 0. So I'm going to have x minus 4 equals 0 and x plus 3 equals 0. So we just use our algebra from way back when, and then I know that here that x equals 4, and then on this equation x would equal a negative 3. And so it doesn't matter if x is 4 or negative 3, we're still going to get a result of 0. It just depends on which parentheses become 0. Same thing goes for b. If I have x minus 8 times 2x plus 1 equals 0, I have to implement the zero product property stating that either x minus 8 equals 0 or 2x plus 1 equals 0. So with that, I have to find what my value of x is for that particular value to equal 0. And then for this one, it would be x equals 8. This one, there's a little bit more algebra involved, so I'm going to say 2x here. Well, this is a plus. Oh, this is a minus. I'm sorry. Minus 1 divided by 2. So then x would equal a negative 1/2. So it doesn't matter if it's either 8 or a negative 1/2. One of these values are going to give you an equivalent of 0, which when we multiply by 0, we're going to get the value of 0. Okay? Next thing in this lesson is being able to find the greatest common monomial factor. So we've been doing problems such as like 2x times the quantity x plus 3, for example. And our job here was to distribute that 2x to our x plus 3, which would give us 2x squared plus 6x. Well, here now we're given problems that look a lot like this. And so we're almost kind of doing like a reverse distributive property here. So what we're going to do is, what I want you to do for these examples is to first look at the numerical values, then look at the variables and see if you can take some values out of that, put them outside the parentheses, and then see what we can come up with when, if we were to distribute, will we get the value of this particular problem. So let's look at this example. I have 16x plus 40y. Now let's look at the numbers itself. Let's look at 16 and let's look at 40. What is the largest number that I could take out of both numbers and it would still give me, you know, a whole number at where I could distribute it? That number would be 8. So I'm going to say, I'm going to put an 8 on the outside, and then I have my, in parentheses would be 2 plus 5, okay? Because if I were to distribute, 8 times 2 is 16, and then 8 times 5 is 40. So now I'm going to look at my variables. I have x and I have y. Since they are different variables, I cannot combine them and then put them on the outside of my parentheses. So I just leave them inside the parentheses. So it'll just be x here and y here. And so that's my answer. Okay. Next, I have example B. I have 3x to the third power minus 45x squared. So let's look at the number. I have 3 and I have 45. So I can take out a 3 in both of them. And then I have in my parentheses 1 minus 15. Okay? Because I go 3 times 1 is 3. 3 times 15 is 45. Now let's look at the x's. I have x cubed and I have x squared. Now that I have a binomial that has a variable, the same lettered variable in both terms, now what I can do is I can pull out that variable and I can take out whatever the least degree is. So here I have a 3 and I have a 2. That means I can take out the least degree, which ends up being a 2. So then from here, I would write in x because I still needed that one more x. And since I've already pulled out an x squared into here, I don't write anything in next to the 15. So if I get rid of that 1 right here, I can rewrite this as 3x squared times the quantity x minus 15. Okay? Looking at this last one, again, I'm going to look at just the numerical values. I have 18 and I have 12. The value that I can take out of both of them would be 6. So then when I have in my parentheses, I can go 3 minus 2. Because 3 times 2 is 18. And 6, not 3 times 2, 6 times 3 is 18. And 6 times 2 is 12. Now I look at my variables. I have x and y, x squared and y, and I have x and y. So I have like terms with x, so I can write that in here. And I have like terms with y, and I can write that in there. And the smallest degree I have for my x is 1 right here, and then they're both 1 for the y. So I can just leave it as 6xy. So now when I look at this 3 right here, I have to put on another x here because 6xy multiplied by 3x will give me that 18x squared y. Important note is if you cannot distribute that and get the same results as your problem, you probably did it incorrectly. So that's a way to double check that your answer here. And then since my second one here with the 2 has x and y on the outside of the parentheses, I just leave that as 2. So my answer would be 6xy times the quantity 3x minus 2. Okay. In this part here, you're going to take two things. You're going to use that greatest common monomial factor to help us solve it. And then also we're going to use the zero product property. So when we're doing example A, I have 4x squared minus 20x equals 0. I'm going to use the greatest common monomial factor first. So here, let's look at the number. What can I take out of 4 and take out of 20 that'll be combined in order for me to put on the outside of the parenthesis? The answer is 4. Okay? So then in the inside the parenthesis, I can write 1 minus 5. Now I look at the variables. I have an x squared and I have an x. Both are the same variable. That means I can write an x on the outside, but the degree of it would have to be to the first power because that's the smallest degree. So on the inside of my parenthesis, I had to put an x here and leave nothing next to the 5. So that means I have 4x times the quantity x minus 5, all of which equals 0. So now I can use the zero product property to help me out. Now I can write this as 4x equals 0, and I can write this as x minus 5 equals 0. For this first one here, I can say that x would have to equal 0, and then for this one here, I have to say x would have to equal 5, and then that would be my answer. Okay? For B, it's important to note that you must make sure that at least one side of the equal sign equals 0. So in order to do that, I'm going to subtract 8y to both sides, which then gives me 0 equals 24y squared minus 8y. So now from here, I can now find my greatest common monomial factor. So I have 0 equals, now I'm looking at the numbers, 24 and 8. I can take out an 8 in this case. And also looking at the variables, I can take out a y. So in the inside, I would have 3y, because 8y times 3y will give me the 24y squared, minus, and now since it's 8y, what do I have to multiply to get an 8y? It would just be 1. It can't be 0 because 8y multiplied by 0 is 0, so it has to be the identity. So now from here, I can use the zero product property to help me solve for y. So I know that 0 must equal 8y, and also 3y minus 1 must equal 0. So for this equation here, y must equal 0, and then for this equation, I must add 1 to both sides, which then gives me 3y equals 1, divide both sides by 3, and now y would equal 1/3. So y in this case must either equal 0 for this to be a true statement, or y must equal 1/3 in order for this to be a true statement. Okay? Last thing is we're going to introduce what is called the vertical motion model formula. Vertical motion model formula, it would be like, say, taking, like, I have like a person, here's my great stick figure of a person, and he's going to jump. He's going to jump up this way, and he's going to come back down because gravity's going to bring him back down. And so we can determine how long he's in the air by, or what his height is, by using this equation. H is its height in feet. T is represented as time in seconds. The object has been in the air. V is the initial velocity in feet per second. And then S is the initial height that he jumps from. Because usually when we're thinking about the floor or the ground, we consider that height at 0. But sometimes, let's say he was like on a rock, and he wanted us to jump off the rock. We want to see how long it takes for him that he's in the air. So sometimes the initial height may be higher than 0. Okay. So if we look at our example here, I have an athlete in the air at a vertical velocity of 2.5 feet per second. How long will they be in the air? So they don't give you any other parameters, so he must have started from the ground. So he starts out at 0. And then he wants to know how long he's been in the air. So he's going to start off at 0, and he's going to jump up, and he's going to come back down to 0. So I can say that h in this case will equal 0. And then I got negative 16t plus, and then it said v and the v here was the initial velocity was 2.5 feet per second, so I can say plus 2.5 t, and then s in this case is the initial height, and the initial height is 0, so I'm just going to leave it like this. So from here, I need to find what t is. I want to know how long they were in the air. So I can say 0 equals, now I can use the greatest common monomial factor to help us out. So let's look at the number first. What can I take out of negative 16 and 2.5? Because the 2.5's there, there's really no clean integer that's going to help me here. So the only thing that, this is actually t squared, I'm sorry. The only thing that it's going to help me here is if I can take out a t. So I'm going to say t, and then in parentheses I'm going to say negative 16 t plus 2.5. Okay? So now from here, I can use the zero product property to help me solve this. So initially t is going to equal 0, which makes sense because before you started the time, you were already on the ground, and so the next time it's at 0 is when you're done jumping. So this next one's going to help us find where the time was that he was in the air. So now I'm just going to be able to solve for t. So now I got negative 16t equals a negative 2.5. When I divide both sides by a negative 16, I get something roughly about 0.56 seconds, because t's in seconds, right? Yes, it is. So I can say that for this particular jump with that initial velocity, that he was in the air for 0.156 seconds. And that is being able to solve polynomials in factored form. Hope this helps. Until next time.